Good morning, guys. Guys, today I'm going to discuss with you the basic principle or rules of derivatives. This is only for AS levels, right? So, the first of all, the rule one. Rule number one is also called as a power rule. Power rule, and it is that one whenever we are going to differentiate with respect to x a function f of x whose power is n, right? This is a function f of x with power n, and we are going to differentiate this with respect to x because this thing d by dx represent that you are going to differentiate the function with respect to x. And if it is d by dt, then you will read it as differentiate with respect to t. So only this variable over in denominator will defines you are going to differentiate with what variable. So okay, the rule says whenever you have the function with the power, this is three-step multiplication case. Then first multiply the power with the coefficient of the function. If no, there is 1. So we write n times and write the function and always make 1 less from the power times differentiate the function. This is three-step case. So let me repeat it. First of all, we need to multiply the power with the coefficient out of the function times we will write the function with the same power and make 1 less from the power, only 1. It can never be 2, 3, less than 1, only 1. And third step says time to differentiate the function whose power you have. This is called the power rule. We will do few examples to justify this rule as a practice. For example, if you are going to be asked to differentiate with respect to x, the function is x power 3. So here you can see f of x representing this x and you have power and the coefficient is 1. So 3 times 1 is 3. We will write the function, we will make 1 less from the power, right? 1 less from the power times differentiate the function whose power we had, that is x. You will see 3x2 and dx by dx is 1. So your final answer is 3x square. Take another example. If you have d by d of x, 1 over x power 3. Here you can see the variable is in denominator with the power. So first you need to apply the rules of indices what so far you have done in O-level classes. So bring it in numerator. You will keep writing d by dx x power minus 3. We will keep writing a d by dx until we start the differentiation. Now we have here we have this function and whose power is minus 3. So applying the rule, power rule, we will say that as the coefficient is 1. So 1 time minus 3 is minus 3. We will write the function and make 1 less from it. And third step, differentiate again with respect to x the function, only the function, right? So we will see minus 3 x raised to power minus 4 and dx comes to be 1. So my final answer is this. Take more example to justify this rule. Say we are going to differentiate x power 100. So what to do? Here you can see we have the function f of x, that is x, and power is n 100. So coefficient of function is 1. So as described in the rule, first 100 times 1 will be 100. We write the function whatever is whose power we have x make one less from the power. Third step says differentiate the function. So we'll get 100x raised to power 99 times dx by dx is 1 always. So our answer is 100x raised to power 99. Okay guys, now after doing these examples, I hope you guys better understood the rule 1, that is power rule. Now the rule 2, rule number 2, that is the multiple of a certain constant, like a constant product rule. We can say d by d of x of a function with f of x, like what to say, whenever a constant figure is going to multiply the function, so you need to write the constant out of the differential and we will only differentiate the function. That means here a is a constant. Here a is a constant number, right? That means I want to say this, whenever a constant is multiply the function, we will write the constant outside and we will only differentiate the function. This is the rule and let's see how it can be implemented in certain questions. Example, like if you have d by d of x, you are going to differentiate 2 time of x3. So what to do, as 2 is going to multiply the function of x3, so first we will write, before differentiation we will need to write it outside and differentiate only the function whose power is this. And now here again we have power, so rule 1, that is the power rule, 2 will remain as it is out of it and his coefficient is 1. So 3 times x power 3 minus 1 times third step dx by dx, as we have done with the rule 1. So it means only here you will apply rule 1 to differentiate. Now finally we will get 3x power 2. Now 3 times 2, that makes 6x power 2 is our final answer. Further take other example for this rule, like d by d of x of 8x5. So here you can see 8 is a constant that's going to multiply with the function x power 5. So first we will write the 8 outside and we will differentiate only the x power 5 by simple applying rule 1, that is the power rule here. So what to do, we let the 8 outside and only this will be done with the last multiplication, right? So what is the coefficient of x5? That is 1. So 5 times 1 is 5. It's 3 steps, differential rule 1. Make 1 less from the power and differentiate the function. We will get it 5x power 4 and dx by dx, well, it's 1. So finally 5 here is a 40, x4 is your final answer. Take another example. If you have d by d of x of 3 upon x2. So what to do? Bring the variable in the numerator. So you will write 3 outside and it can be x raised to power minus 2. So again apply the power rule here. You write the power, make 1 less from the power and differentiate the function. 3 times it will become minus 2 x power minus 3 and dx by dx, this is 1. Minus 6 over x3 is your final answer. I hope you understood. Here we are going to apply now the rule 3. Rule number 3, that states d by d of x of a constant number c, where c is a constant, and as you can see here, we don't have any function of x, only it's a purely constant which is going to be differentiate. So whenever you see a constant without a variable with which you are going to differentiate, that it directly approaches to 0. So we can say differentiate of constant number is always 0. And you can check it how. I can explain you with example like if you have d by d of x of 2, how it be 0? So you know d by d of x of 2 can be written as 2x power 0, because we know any number power 0 is always 1, right? So here you apply the rule to first bring the constant outside and let the function with the power. Now apply the power rule here. What to do? We need to multiply the power with the coefficient of the function and always make one less from it, 0 minus 1, and differentiate a function, right? Here you can, so whenever 0 is multiplied with any term, it makes it 0. So finally you will get the 0. So you can see in this, with this example, that whenever we are going to differentiate any constant with respect to some certain variable which is not involved with the function given, so its differential is always 0. So take another example, d by d of x of say 5. So you can directly say that is 0 because it doesn't keep any variable with it. So no need to proceed like first make x power 0 and like do this one. Directly you can write the differential of a constant. I'm going to write here differential of a constant always 0. So this is the rule. Whenever you see, you can proceed. Finally, we have another rule or number 4. That is rule number 4. It describes whenever you have sum or difference of two or more functions like f of x plus or minus